Good? Okay, here we go. So number one says y equals negative 3x times 2x squared plus x minus 6. And the goal is to graph this, identify the roots, and the end behavior. So we're sketching, and I think I want to just make this very clear. Do not try to graph this like perfectly. We're just sketching. Okay, we're just sketching. So, step one, you want to have some steps here. So step one is going to be identify the roots. Identify the roots. So, how do we find the roots? This is from Thursday's lecture last week. How do we identify the roots of a polynomial? What do we do? Fernando? We're going to do box and diamond? On what? Sorry. We will do that. We need to do one thing before that, though. Matthew?
Wait, would 3x have a root of 0?
Okay, but how do I identify that? That's correct. What is the step that I need to take here? We talked about a general step. Anytime you want to find roots, you do blank. Fill in the blank. Daniel.
Factor.
It's already factored. What do I do next?
Plug in 0 or
Plug in 0 for what?
for x.
Plug in 0 for x. That'll tell me the y intercept. Mendez?
Y.
Plug in 0 for y. Yes. Plug in 0 for y. We must know this. We must know this. If you want to find the zeros, set the function equal to 0. What do I do next? Oh boy. A lot of people haven't done the homework due tomorrow. You'll have a long night tonight. Daniel.
So you put that. Isn't it a little thing you distribute?
You could distribute. That's going to make your life harder. Then you'll have to refactor it. You'll say? We will get there. It's one thing I do before the box. Yeah.
You can like separate these equations.
Yes, you split them up and set each piece equal to 0. 0 product property. Yeah, for sure. Divide both sides by negative 3. So x equals 0. That's one root. And over here, now, Fernando's step comes through, box and diamond. What Dulce said as well. I think most of y'all can do this on your own. If you need to look up for help, great. I think most people are good with this.
No, it's 4 negative 3.
Thank you. Too smart, Lucia. Please verify that you get what I get. Questions? Any questions on solving the roots? All right. So now I would go ahead and draw my axes and go ahead and just plot these roots. So here's a root at x equals 0. I'll label them. Here's a root at x equals negative 2. And here's a root at 3/2. By the way, 3/2 is the same as 1.5. So we got the roots. Step 2, determine the degree. Determine the degree. Daniel?
Odd. Well, it's like
Odd?
because once you distribute, it's going to be x to negative 6x cubed.
Yes. look at, so this is exactly how you want to approach the problem. Here's x squared times x. That means if you were to distribute this, I wouldn't recommend distributing it. It'll take a lot of time. If you were to, you would have x to the first power times x squared. Bases are the same. You're multiplying. Therefore, you add the exponents. 1 plus 2. So the degree in this case is 3. So we have an odd degree polynomial. Odd degree polynomial. Michelle? Yep. So this is degree 1, multiplying it by this. So if I were to multiply all this out, I won't do it, but as Daniel said, you do this times this, and you just distribute this. And I would have negative 6 x cubed as the first term. X cubed would be the highest exponent as a degree 3. Step 3 is identify the leading coefficient. Remember, LC is my abbreviation for leading coefficient. So leading coefficient here is just, Josh?
3.
Say it again? 3? The degree is 3. What is the leading coefficient? Negative 6. Remember, leading coefficient is the number in front of the variable with the highest exponent. Josh?
Does that mean it would go, it would be off, so it would go like this?
It would go like...
Like this, up, or would it still be down?
No, yeah. So let me draw it. Sorry, my ability to see that and comprehend that is very low. Let me draw it. But the important thing is to find the leading coefficient, you take this negative 3, multiply it by this 2 to get the negative 6. So this is negative 6, which means the graph starts down here. Negative leading coefficient means on the positive side we go down, so let's come up, down, up. I know what he's doing. And here you have it. Again, we have no idea how tall this graph goes or how low this graph goes. Doesn't matter. We're sketching. We are sketching. Don't get hung up on getting it exactly right. This is just a sketch. And the sketch makes sense. Why? This odd degree polynomial, these go in opposite directions. The leading coefficient is negative, so this goes downstairs. Joshua.
You always start on the right side.
Always start on the right side. Makes life very easy. Yep. So now what are we talking about when we say end behavior? End behavior is the following. It says what happens on the ends. Matthew?
I had a quick question.
Yep.
So when you plot the points there, never, like the line would never just kiss it, or would it just like...
It will, and that's going to be coming up soon. Yeah, great. So end behavior, right, is just what happens on the two ends. That's it. So the way I would write this is the mathematical way is saying as x goes to infinity. So as x gets really big, way out here, y goes downstairs. So y goes to negative infinity. That's half of the end behavior, because that's one end. Now I got to talk about the other end. So the other end is as x goes to negative infinity. So way over here, as x goes way over here, y goes upstairs, y goes to positive infinity. This is what we mean by end behavior. What happens on the two ends of the graph? Questions? Daniel?
Put like in parentheses.
You can just like do like this. This is end behavior.
Like infinity, slash infinity.
No, you need to write it out. This is the notation.
Oh.
Yeah, we need to write it out like this. Yeah. Questions? All right, let's keep going. Let's try, so let's pause and switch the video over here.